Hey, good evening, everyone, and welcome to Dosage Calc with Jeff. I'm here to help you with all your nursing level 1 dosage calc needs. Before we continue, however, please be sure to like and subscribe and kindly help me with my YouTube analytics. Also, if you have any specific requests for future episodes, drop me an email or message me here with a comment and let me know what content you'd like to see. Tonight, we're going to pull from one of Nurses Lab's test banks for a dosage calc by weight problem. And the problem tonight, the one that we're going to be solving tonight, is um, interestingly juxtaposed with these amazing deals on boots, whatever. A primary healthcare provider ordered Rocephin for a 4-year-old child with a lower respiratory tract infection. The dose required is 20 milligrams per kilogram per day, divided twice a day, administered per dose via IV. The child's weight is 29 pounds. The drug comes pre-diluted in a concentration of 10 milligrams per milliliter. How much of the medication will you administer in milliliters? Fill in the blank, record your final answer using 1 decimal place. So we do know the rounding rule. They want it 1 decimal place. There's a couple of things that you really need to pay attention to with this problem, just to make sure that you don't get confused and kind of get it mixed up with other things. One of the things that I had seen already was that a lot of people were getting or having a problem with the whole, is it daily or is it daily per dose, or how many doses per day if this is the whole amount of day. You don't want to let that get you tripped up, because that'll give you the wrong answer, and when it comes down to actual nursing practice, that could really be harmful to the patient. So we're going to take a couple of aspects of here. We know that this is a 4-year-old child. Um, with a lower respiratory tract infection. The dose required is 20 milligrams per kilogram per day, divided in twice a day, so that's 2 times daily, divided twice a day. So we want to make sure we get that right. This is the 20 milligrams per kilogram per day. That's the whole day, but you want to divide it evenly into 2 individual doses, administered per dose via IV. The child's weight is 29 pounds. We're going to be converting that to kilograms here. Let's see. The drug comes pre-diluted in a concentration of 10 milligrams per milliliter. So let's come over to my handy dandy little loose leaf page, and we're going to start working on this problem. And I'll show you how easy this is so that we don't have to get hemmed up with this every time we see something with some interesting verbiage like that. All right? So let me erase all of my stuff here. All right. So the first thing that we're going to do, we're going to put some basic information down. We know that the drug it needs to be given is 20 milligrams per kilogram per day. We know that the child's weight is 29 pounds. We know that it comes pre-diluted as 10 milligrams per milliliter. And we know that this has to happen twice daily. So we say that this whole dose, which is 20 milligrams per kilogram per day, has to be divided evenly into 2 doses. We don't change the amount. It's not going to be 10 milligram or 9 milligrams in the morning and 11 milligrams in the afternoon. That's not how you do things. So it's got to be divided evenly 2 times the day and 2 times daily. The other thing, well, let's see, 20 milligrams per kilogram per day. Okay, so let's start setting this up. We're looking at 20 milligrams per kilogram. I'm going to put my little bar here. We know that 1 kilogram is equal to 2.2 pounds. We know that it comes pre-measured, and 1 milliliter contains 10 milligrams. Now, I switched up the fraction here Even though it didn't say that in the first time that I wrote it, I switched it up so that I could have the milligrams on one in the numerator and one in the denominator. If you have them both in the numerator or both in the denominator, you'll get milligrams squared or milliliter squared, and that doesn't really play too much into dosage calculations. So you want to really be able to get rid of those. The end result is they're asking for, let's see, what are they asking for? They're asking for how many milliliters. So the only unit of measurement that we want left over is milliliters, right? So let's come back here. This is the only. I'm going to get this right. This is the only one we're looking for is the milliliters. So when we write this out, we want to make sure that we can cancel out like terms on the numerator and the denominator so that we can get rid of them and only be left with what we're looking for. For example, here we can cross out kilograms and we can cross out, let's see, oh, we missed a step. So we need to also take into consideration that this client, this patient weighs 29 pounds. So I'm going to put 29 pounds over my little dude right there. So now we have pounds in the numerator, pounds in the denominator. We have kilograms and kilograms, and we have milligrams and milligrams. Now, it's really important, not that you would ever get to a point where you're going to be giving 200 milligrams of whatever. Maybe you will, but what you don't want to do is you don't want to change 200 milligrams to 0.2 kilograms. For whatever reason, sometimes people see milligrams and kilograms and think they're just a thousandth off. But in reality, those are two separate separate identifiers because they refer to different aspects of this whole process. So just because somebody says that they have 12 kilograms doesn't mean that you wouldn't weigh a human being in milligrams. You'd weigh them in kilograms and kilograms with a decimal point. So here we're getting rid of milligrams and kilograms. We're keeping them as they are. We're getting rid of pounds. And our equation becomes 20 times 29 divided by 2.2. Now, there's a reason why I did not include the ones in here. Oh, nope. Of course, I should probably put the whole thing. 2.2 times 10. There's a reason why I didn't put the ones in here. It's because when you put the ones in here, it doesn't change the outcome of the equation. Multiplying by 1 or dividing by 1 gives you that same number back. So instead of writing times 1 times 1 times 1, all of that's completely unnecessary. You don't have to do that. So whenever you see ones in the equation, just leave them out because it's not going to change. It's not going to add or subtract anything to the final answer. So the only parts of this problem that we're looking at is the 20 and the 29 on the top, and the 2.2 and the 10 on the bottom. So when you multiply this out, you get, well, let me get my calculator out, 20 times 29 over 2.2 times 10. And the answer winds up being 290 over 11, but we don't work in irregular fractions, so we're going to say the answer is in fact 26.36 with both repeating. We're not quite done with this problem though. We still have the matter of this is the whole dose. It's 26.36 over divided into two equal doses so that we can give it twice a day. There's a couple of ways that you can do this. You can literally just take the end result and divide it into 2. And so 26.36, let's see. So I can get an actual divided by 2 is equal to, it's going to be 13.1818181818. So it's going to be 13.18 repeating, which rounds up to 13.2 milliliters twice daily. You could certainly do it like that, or you could add in another element to the equation up top. So let's get this out of the way for right now. Let me try to erase this without erasing all of my other work. God dog it. Hold on. Let's try that again, Jeff. So you could add in another element to this equation and say, over a 24-hour period, right, you're given the dose twice daily, right? So that's essentially every 12 hours. So really what you want that to look like is every 12 hours over a 24-hour period, that will give you the answer that we're looking for. Now you can take that 12 over 24 and just turn it into 1/2 if you wanted to. The answer is still going to be the same. So let's take a look at it, and we'll say 20 times 29 over 2.2 times 10 times 2. Or you can also say it times 12 and times 24. It doesn't really matter. It is going to be the same. So we say, let's look at my calculator, 20 times 29 times 12 over 2.2 times 10 times 24. The answer is still 13.18 repeating, which rounds up to 13.2. Another way that you could think about this is that if it says that it's going to be twice a day, you already know that 24 divided by 2 is 12. So the fraction is going to be 12 over 24. Now, what happens if it says 3 times a day? All right. Well, 3 times a day is going to be every 8 hours. Okay. So you can say, instead of saying 3 times a day, which is literally dividing by 3, you can multiply. Where did that little line come? You can multiply, instead of by 12 over 24, you can put 1/3. That's 3 times a day. Multiply that whole equation by 1/3. What if it's 4 times a day? Well, you multiply that whole equation by 1/4. Because when you take a number and you multiply that number by 1/4, that is the same as saying that number divided by 4. These are two identical equations. It's the same thing. A times 1 over 3 is the same thing as A divided by 3. So what you can do is say, well, how many times a day is this going to happen? I'm going to put 1 over that number and multiply the entire equation by it, and you will get your answer. That is really the best way to do it. It prevents a whole lot of other steps. You just say, I want this number. If I have this amount of times per day, then I'm going to put 1 over that number and multiply the entire equation behind it, and you'll get your answer every time. Thank you for joining me tonight. Let me know if I can address any specific problems or questions you might have. Please feel free, or be sure to like and subscribe to my videos. It does help me out with my analytics, lets me know who's watching and what y'all want to see. Thank you very much. Y'all have a great night. Bye.